Good afternoon, one and all. I am Dr. Radhika Deshmukh, Assistant Professor, Sri Shivaji Science College, Amravati. First of all, I am thankful to the organizer for arranging this conference, that is ISCA sponsored. This conference gives us platform to express our views and present the paper. I am going to present here a paper on green synthesis of nanoparticle and its applications. The content is abstract, introduction, approaches for nanoparticle synthesis, method of synthesis, advanced method of synthesis, factors affecting green synthesis of nanoparticles. In the abstract, nanotechnology can be defined as manipulation of matter such that any one of its dimensions falls in the nanoscale range. Matter at this scale is characterized by material properties significantly different from molecule atoms or bulk atoms. The combination of two or more different metal is a metallic alloys, and that nanoparticle possess physical chemical properties. They have a major role in the development of drugs, catalysts, sensors and pesticides. The synthesis of nanoparticle is usually achieved via chemical and physical methods. This green synthesis is the best way to move towards more environmentally friendly processes. Green synthesis routes have been proposed as a cheap and environmentally sustainable. They can be lead to the fabrication of nano objects with controlled size and shape. In this review, we summarize the fundamental processes and mechanism of green synthesis approaches, especially for metal and metal oxides. In the introductory part, we tried to focus on the different methods of green synthesis that we are using up till now. And in this article, we try to find out the advanced methods of green synthesis. Approach for nanoparticle synthesis. There are two approaches, top down approach and bottom up approach. In the top down approach, chemical stretching, substrating and laser fabrication and mechanical methods, all these we are using. And in the bottom up approach, there are sol gel processes, laser pyrolysis, anaerosion pyrolysis and vapor depositions. These methods we are using. Methods for nanoparticle synthesis are three types: physical, chemical and biological. But physical and chemical methods are hazardous to the environment. Chemical method may create the toxic substance in this environment. So, we adopt biological method, which is the best way to find the nanoparticles, and these nanoparticles having number of applications. Biological method contains the green synthesis. The green synthesis of nanoparticles, that nanoparticles can be generated in various ways, maybe physical, chemical or biological. The major drawback of chemical of nanoparticle generation is the toxic solvents and chemicals, which cause a great problem of harm to our already suffering environment. Therefore, need for a different alternative nanoparticle generation was felt across the globe, which led to the development of green nanotechnology. It is a simple, co-effective and environment friendly and has gained a lot of importance in the recent past. Green nanotechnology that can be defined in general as the use of biological routes like bacteria, fungi and plants for synthesis of nanoparticles with the aid of various biotechnological techniques. There are various biotechnological route for generation of nanoparticles: bacteria mediated nanoparticle generation, fungi mediated, actinomycetes mediated, yeast mediated, algae mediated and plant mediated nanoparticle generations are there. We try to explain all these. There are various factors that affects on green synthesis: the pH of reaction medium, reaction temperature, method of production of technique used, pressure and time. All these factors affect the green synthesis of nanoparticle. We also focus on all these factors. In the concludatory part, green nanotechnology has emerged as a major tool for production of nanoparticles that are environment friendly, non-toxic and cost effective. It holds immense potential with various areas of applications it to be explored. Using green synthesis, we can synthesize different varieties of nanoparticles that can further be applied in a diversity of applications. Synthesis of nanoparticle using greener methods is affected by various factors such as pH, temperature, incubation time, which must be taken into consideration to obtain the best results. This article provides brief information about various approaches and methods in synthesis of nanoparticles. More advancement and investigations in the field of green nanotechnology will surely help expand our knowledge base and improving our understanding of principles of green nanoparticle synthesis and factors affecting that synthesis, which will further determine more efficient applications of nanoparticle in different areas of interest. These are the references. Thank you.